Good morning everyone. Today we shall discuss next part, that is a isoperimetric problem. This is the particular types of problems, isoperimetric problems means these are the particular types of problems which we have to discuss here. So actually this is the bit which we have to start today, that is isoperimetric problems. Yesterday we have seen that the Brachistochrone problem, this is a particular type of a problem. In this way we have to discuss now the particular type of a problem, that is isoperimetric problem. So also all these problems are based on the Euler's equation, Euler's special conditions. So we shall start today the isoperimetric problem. 1 minute. We shall discuss what is meant by isoperimetric problems. We shall discuss. It is necessary to make the integral. It is necessary to make the integral see this is the definition of the isoperimetric problem. These are the particular types of problems we have to discuss here. So isoperimetric problem, it is necessary to make a given integral, actually this is the given integral, I is equals to integral from x1 to x2 f of x comma y dash dx, subject to the constraint j is equals to integral from x1 to x2 g of x comma y dash dx. Actually this is a constant. Such a problem involve one or more constraint condition. Okay, this type of a problem are called isoperimetric problem. See this is the definition of the isoperimetric problem. It is necessary to make a given integral I is equals to integral from x1 to x2 f of x comma y dash dx, subject to the constraint, that is a constant condition we have given j is equals to integral from x1 to x2 g of x comma y dash dx, which is equals to constant. Such problems involve one or more constant conditions, then this type of problems are called as isoperimetric problems. Means we have given an integral with the constraint, under some condition there is an equation, integral equation, and that equation is the constant. If problem of the integral given with the constraint, then such a problems are called as a isopermic problem. See this type of problems are called as a isopermic problems. So now how to solve such a problems, how we can evaluate such problems, we shall discuss here. What we have to do students, सबसे पहले क्या करना है, देखो हमें now see here, this type of problems can be solved by using some particular condition. That is the, we have studied how to solve the single functional equations, functional integrals by using the Euler's condition. But today we shall discuss, today we shall solve this problem under some different condition. We shall discuss this, okay. Now this type of the necessary condition, see here. Now how we can solve these problems here? This type of functions can be solved by using necessary condition. By using the necessary condition for the integral such as I is equals to integral from x1 to x2 f of x comma y dash dx. Suppose this is 1. J is equals to integral from x1 to x2 g of x comma y dash dx. If we consider this as a second, now the for necessary condition for the integral, suppose if we consider the necessary condition for the integral from 1 to, we can write, how we can write here? Suppose h is equals to f plus lambda g. We consider another function, that is f plus lambda g. Lambda is the constant, where lambda is called as a Lagrangian constant, where lambda is called so therefore the condition for the integral Lagrangian multipliers or multiply, that is a constant, there is no problem. Lagrangian multiplier, or it is called as a Lagrangian constant of multiplier. Okay, you can write Lagrangian multiplier also. Okay, now the integral from x1 to x2 h dx to be an extremum is the condition. What is that condition? Dou h by dou y is like a same Euler function plus minus d by dx of dou h by dou y dash, which is equals to 0. See this integral, which is said to be extremum if it's the necessary condition for the integral from h1 to from x1 to x2 h dx has and extremum value if this condition satisfies dou h by dou y minus d by dx of dou h by dou y dash, which is equals to 0. Suppose this is equation number 4. आपण याला 3 देऊ. So this is the 4, or we can write, or it can be written as h suffix y minus d by dx of hy dash, which is equals to 0. According to the Euler's condition, we can say that it is the extremum function. According to the Euler condition, we can say that the extremum function. We determine the Lagrangian multiplier. Here we can determine the Lagrangian multiplier multiplies lambda together with the constant constants of integration. Constant of integration. Here we can find the value of lambda or multiplier lambda with the constant of integral. Okay. Integration arising in the integration arising in the solution G, that is Euler's equations, and integral J having given constant value. Constant of integrals. See this. Now how to solve this problem? I shall again revise this. See this. The problem, isoparmetric problem, the necessary condition to make the integral I is equals to this, j is equals to this. In this condition, one of the integral is constant. Such a problems involve one or more constraints condition. Then this type of problems are called as a isoparmetric problem. Now how to solve the isoparmetric problem? Suppose I is equals to this integral of f, j is equals to integral of g, which is a constant. J is equals to integral of g, which is a constant here. Then we can introduce new function h. The integral from 1 and 2 we can introduce in terms of h. H is equals to f plus lambda g, where lambda is called as a Lagrangian constant or Lagrangian multiplier. The integral of x1 to x2 h dx to be extremum. या दोघांचं कंडिशन घेऊन f plus lambda g, where g is the constant integral. So integration ची value constant असेल. So we can write this value as a extremum if this condition satisfies, that is Euler condition, dou h by dou y minus d by dx of dou h by dou y dash is equals to 0. That means we can write hy minus d by dx of hy dash is equals to 0. Here lambda is called as a Lagrangian multiplier, and we can obtain this value of Lagrangian multiplier lambda with the constant of integral given by h and g, given by the g is a constant. See this, integral g is a constant given by g by using the Euler's equation. Okay, now we shall solve the problems based on this. आता याच्यावरचे आपण प्रॉब्लेम्स घेऊ. ओके, म्हणजे तुम्हाला हा कंप्लीट थेरी समजेल. वर्षा ठाकूर, सोनाली पाटील, पल्लवी कराडे, एवढ्या लेट जॉईन नाही व्हायचं मध्येच कधी. तुम्हाला अटेंडन्स आता टाका म्हटलं नाही मी. So we can write this. Now problem first. Find the extremal of isopermic problem. Problems or examples. त्यामध्ये first घेऊ. Find the extremal of the isopermic problem, isoparametric problems. Problem I is equals to I of y of x, which is equals to integral from x1 to x2 y dash square dx, and given that integral from x1 to x2 y dx, which is equals to constant c, that is equals to constant. Okay. Now we have to find out the extremal of this isoparametric problem. What is the condition of the extremal of the isoparametric problem? If I is given, j is equals to constant, which is also given. Here j is a constant, note that this is a constant. I is given, j is a constant integral. Then we have to form the function h is equals to f of, h is equals to f plus lambda into j. And this function h, which is the combination of f and g, is said to be extremal or extremal if the condition dou h by dou y minus d by dx of dou h by dou y dash is equals to 0, or hy minus d by dx of hy dash is equals to 0. This is the Euler's condition. Okay. Now we shall move towards given functionals equation is I of j of y, which is equals to x1 to x2 y dash square dx, having the condition what is that condition? Having the condition integral of x1 to x2 y dx, which is equals to c. C means the constant. Suppose this is 1, this is a second, then we have to find out the extremal. Then we have to combine the condition for I and j. Suppose this is a j. So we can form the condition. This is suppose f and this is a suppose g. Constant जो function असतो त्याला g consider करा. So we can write this as, आता याला combine मध्ये कसं घ्याल मग? So here सांगाले स्टुडंट स्मॉल f म्हणजे किती आहे रे? स्मॉल f which is equals to y dash square, small g is equals to y. Now we can define h is equals to f plus lambda into g. Lambda is the constant of multiplier. So we can write f is equals to h is equals to, प्रतीक्षा शेवान काय वेडी आहे का तू? मध्येच कशाला जॉईन होते? का तुला प्रेझेंटी टाकायला येत असते का तू? अंजली हंबीर का प्रेझेंटी टाकायला येते का? करू नका ना कॉलेज, कशाला येतात तुम्ही? f is equals to h is equals to f plus lambda g. Now put the value of f means y dash square plus lambda into g means y. So we can write this as, now we can solve this. What we have to condition? We have to use the condition hy minus d by dx of hy dash, which is equals to 0. Now we have by the Euler's condition, integral from h1 to h2, integral from x1 to x2 h dx to be extremum, if काय कंडिशन आहे, hy minus d by dx of hy dash, which is equals to 0. Suppose this is equation number, which is that equation 3, this is equation number 4. That means we have to put the value hy and hy dash. For the purpose of putting the value hy and hy dash, first of all differentiate equation 3 partially with respect to y and y dash. From equation 3, differentiating equation 3 partially with respect to y and y dash. So we can write hy, h suffix y. काय येतं रे सांगा बरं स्टुडंट, how we can take the derivative of this function hy चा derivative काय येतो, derivative of h with respect to y means h suffix y. Now you tell me what is hy, partial derivative of h with respect to y. So we can write this as hy equals to, हा रे सर्वांनी सांगा रे hy चा आन्सर काय येतं, मला पाहू द्या आन्सर, कोण कोण काय आन्सर देत असतं ते. hy is equals to lambda, also hy dash equals to, we can write this value hy dash means we have to take partial derivative of h with respect to y dash. So y dash square चा derivative काय येतो, 2y dash. So put this value in equation 4, put in 4. That means in the Euler condition hy means lambda minus d by dx of hy dash means 2y dash, which is equals to 0. So lambda minus derivative, again we have to take the derivative with respect to x, then we can write 2 into y dash चा डेरिव्हेटिव्ह किती असतो रे, फास्ट आन्सर दे, चला मला पाहू द्या, पाहत असतो मी कोण आन्सर द्यायला लागले काय नाही, कोण प्रेझेंटी टाकून जातं, कारण जे प्रेझेंटी टाकून जातात ना ते आन्सर देत नाहीत, तर कोण प्रेझेंटी टाकून जातं काय नाही ते मी पाहत असतो आणि त्यांना परीक्षेला नाही बस देत, तुम्ही काही केलं तर नाही बस देत. ठीक आहे, y double dash which is equals to 0. So now our aim is to solve this integral. So we have to solve this. Now we can solve this. Therefore minus 2y dash double dash which is equals to minus lambda. Therefore y double dash is equals to lambda upon 2. Y double dash is equals to lambda upon 2. So we can take the integration. आता एक integration घ्या. By integrating then what will happen? Double derivative we can change into the single derivative. Double derivative means d2y by dx square. Actually that can be written as a d by dx of d2y by dy by dx, dy by dx. So whatever may be. Now if we take the integration on both sides, then this first derivative will be cancelled. So remaining term is dy by dx, which is denoted by y dash, which is equals to lambda upon 2 is a constant, and integration of constant is with respect to x, plus we can say a means the constant of integral. A means the constant of integral. So again we have to, again by integrating, derivative of y dash psi integration y, which is equals to lambda upon 2 constant I is it is x psi integration with respect to x is x square by 2 plus ax plus b. Here b is the constant of integral. Okay. So y is equals to lambda x square divided by 4 plus ax plus b. Suppose this is equation number 5. I think it will be 5. Okay, this is a 5. Now here in this equation, there are 3 constants. There are 3 arbitrary constants, that is lambda, a and b. Now these 3 arbitrary constants can be determined by the isoparametric boundary conditions. Now we can determine by the isoparametric condition, but actually in this isoparametric conditions we have not given the boundary conditions. इथं आपल्याला boundary conditions दिले नाहीत. Boundary म्हणजेच x1 x2 दिलेले आहेत. x1 x2 means these are the general values. We are not given the boundary condition in this problem. So we can't find here the values of a and b. So this is the required, this is the required general solution, because this is a general solution because it contains the arbitrary constants lambda a b of the isoparametric problem. Isoparametric problem which has an extremal function. Note that here the arbitrary constant lambda comma a comma b can be determined by using the boundary conditions. Okay, but in this problem the boundary conditions are not given. So see this, in this problem we have not given the boundary conditions, so we can't calculate the particular solution of the extremal of h, extremal of h. Okay, so we can't find the particular solution, so this is the required general solution which is the extremal for the function h. Okay, now we shall move towards the second problem. Find the extremal of the problem. Okay, आता आपण second problem कडे जाऊ. Find the extremum of, find the extremal of the functional I is equals to integral from 0 to pi y dash square minus y square dx under the condition y of 0 is equals to 0, y of pi is equals to 1. We have given the boundary conditions subject to the constraints integral from 0 to pi y dx is equals to 1. Okay, subject to the constant y dx is equals to 1. आता आपण actually we have given this is the constant integral from 0 to pi y dx, and this is the functional I is equals to integral from 0 to pi y dash square minus y square dx. Then we have to find out the extremal of the functional under this constraint. That means we have to use the method of isoperimetric problems. So we have to use the method of isoperimetric problems. Okay, ठीक आहे. सर्वांनी आता प्रेझेंटी टाका एका मिनिटात. So given functional is I of y of x which is equals to integral from 0 to pi y dash square minus y square dx. Suppose this is 1. Under the condition having a boundary conditions हाँ ते मेंग सेटे आता प्रेझेंटी घे. जे विद्यार्थी आता टाकतात ना त्यांचीच प्रेझेंटी घे. अंडर द बाउंड्री कंडिशन y of 0 is equals to 0, y of pi is equals to 1. Is it okay? Now this is the given condition. Now we have to discuss also given constraint is constant means the particular condition that is integral from 0 to pi y dx is equals to 1. Suppose 2. Now we can define the next function h. Now here small f is equals to. Now you tell me student f म्हणजे काय? हाँ आता याच्या नंतरचे अटेंडन्स नका घेऊ. या नंतरच्या घ्यायच्या नाहीत अटेंडन्स आता. हाँ f means y dash square minus y square, g means y. See this f and g. Now we can define. So therefore h is equals to f plus lambda g. So put this value h is equals to f means y dash square minus y square plus lambda into g means again y. So we can write h is equals to y dash square minus y square plus lambda y. Suppose this is equation number 3. Now the extremal solution is under the condition of Euler's equation. Now by the Euler equation ठीक आहे, काही अडचण नाही. आता ते माहीत झालं काय काय करावं लागतं. ऑयलर इक्वेशन, त्या ऑयलर इक्वेशन मध्ये नंतर घेऊन द्या टाका येतं. आता डिफरन्शिएटिंग इक्वेशन 3 पार्शियली with respect to y and y dash. Okay, now you tell me student what is the h suffix y. So hy means partial derivative of h with respect to y. काय येतो सांगा रे सर्वांनी. y dash square चा derivative 0 because we are differentiating partially with respect to y, so it will be 0 minus 2y plus lambda. That means hy is equals to lambda minus 2y. Is it okay? Also hy dash equals to, again we have to take the partial derivative with respect to y dash of the equation 3. So hy dash will be derivative of 2y dash square चा derivative काय तो y dash square चा derivative 2y dash. ओके, हा व्हेरी गुड. भाग्यश्री देवके, अनिता राजमाने दोघांनीच आन्सर दिला का? मोहिनी नाडे, व्हेरी गुड. सो नाउ बाय द Euler's equation, what is that Euler's equation? We can write hy minus d by dx of hy dash which is equals to 0. So put hy means lambda minus 2y. See this? hy means lambda minus 2y. Again hy dash, how we can write hy dash? Hy dash means 2y dash minus minus d by dx of 2y dash which is equals to 0. So lambda minus 2y minus 2y double dash which is equals to 0. So we can write this as dividing by 2. So minus 2y double dash minus 2y which is equals to lambda. Therefore y double dash minus plus y, this will be the minus, plus y which is equals to lambda upon 2. Now this is the differential equation. Actually this is the differential equation, second order differential equation. Now our aim is to solve this second order differential equation. Okay, आता हा जो आपल्याला सेकंड ऑर्डर डिफरन्शियल इक्वेशन सॉल्व करायचे, सो वी कॅन राइट धिस इन द फॉर्म ऑफ, सो आता यू नो हाउ टू सॉल्व द सेकंड ऑर्डर डिफरन्शियल इक्वेशन in the M.Sc. first year we have studied how to solve the different types of ordinary differential equation, first order, second order, third order, nth order. So I am not going to revise that. You have to check how to solve the differential equation there in the syllabus of M.Sc. first year. You know. So this can be written in the form of an operator equation. So we can write this in the operator equation, d square plus 1 y which is equals to lambda by 2. Okay. So here the auxiliary equation is d square plus 1 is equals to 0. आठवत आहे का पाय? B.Sc. ला पण झालेला आहे, M.Sc. ला पण झालेला आहे, त्यामुळे आता इथं परत घ्यायची गरज नाही आहे. सो वी कॅन राईट d स्क्वेअर इज इक्वल्स टू -1 और वी कॅन राईट r स्क्वेअर, याला r स्क्वेअर सुद्धा लिहितात. सो प्लस और माइनस रूट -1 that is equals to I. Therefore the auxiliary equation having a complex root or imaginary roots, therefore the complementary function is, the complementary function is, so we can write the complementary function is, therefore C of complementary function is equals to C1 cos x plus C2 sin x, because here we can write, आता हे खूप डिटेल मध्ये अगोदर झालेलं आहे, तुम्हाला हे सुद्धा झालेलं आहे. कुठे आहे? we can write alpha plus or minus I into beta. So its solution, that means its complementary function can be written as e raised to alpha x C1 cos beta x plus beta x. This is the solution, that is a complementary function. Similarly, we can find the particular integral also. Particular integral आठवत आहे का पहा, 1 upon d square plus 1 into lambda by 2, which is the constant. So we can write this as, now d is the 0 condition, so we can write 1 upon 0 plus 1. Okay, put this value d, means 0 plus 1, we can write lambda by 2 into e raised to 0x. So it will be the lambda by 2. So particular integral will be lambda by 2. हे झालेलं आहे अगोदर. Therefore the required solution is, therefore the required solution is y is equals to complementary function plus particular integral, that means c1 cos x plus c2 sin x plus lambda by 2. Is it okay? हे पहा, याचं सोल्युशन तुम्हाला M.Sc. फर्स्ट इयरला झालेलं आहे. हाऊ टू सॉल्व दिस सेकंड ऑर्डर ordinary differential equation. You have studied in the M.Sc. first year also, in the B.Sc. second year also. So I am not going detail. So now our aim is to solve this. This is the required solution. This is suppose equation number, I think 6. Is it 6? Okay. This is the required solution, but this solution is a general solution. Why we can say that this is a general solution? Because it contains the arbitrary constant. It contains the arbitrary constants. Now we have to find out the particular solution according to the boundary condition. Now the arbitrary constants, the constants C1, C2 and lambda, can be obtained by the boundary condition What is that boundary condition? We have given y of 0 is equals to 0, y of pi is equals to 1. Now put, actually we have y of x is equals to c1 cos x plus c2 sin x plus lambda by 2. Put x is equals to 0, so y of 0 is equals to c1 cos 0 plus c2 sin 0 plus lambda by 2. Then y of 0 is also 0, so we can write 0 is equals to, हाँ सांगा रे व्हॅल्यू काय ते, cos 0 ची व्हॅल्यू किती? Now you tell me student, what is the value of cos 0? Value of cos 0 is cos 0 is 1, c1 into 1, sin 0 is 0, means we can write c1 plus 0 plus lambda by 2, so we can write this as c1 is equals to minus lambda by 2. Okay, there is no problem, we can obtain the value of c1 in terms of lambda. Also, इथं वाटलं तर ब्रॅकेट मध्ये टाका y of 0 is equals to 0. Also y of pi. Also we have given the second boundary condition, that is y of pi is equals to 0. That means replace x is equals to pi in this equation. Then y of pi is equals to c1 cos pi plus c2 sin pi plus lambda by 2. Now you tell me student, what is the value of cos pi? Also you have to write the value of sin pi. Now the value of cos pi means 180. So y of pi is already given. What is the value of y of pi? Y of pi is 1, which is equals to c1 into minus 1 plus c2 into 0 plus lambda by 2. Is it okay? तर अशा पद्धतीने आपल्याला व्हॅल्यू घेता येईल. c1 ची व्हॅल्यू लिहा. Therefore we can write c1 is equals to lambda by 2. c1 is equals to lambda by 2. Now suppose this is equation number 7, this is equation number 8. Then from 7 and 8 we can write the value of from 7 and 8. Therefore we can write the value minus lambda by 2 which is equals to minus lambda by 2. This means lambda by 2 plus lambda by 2 is equals to 0. Okay, 1 minute. इथं 1 आहे ना, सॉरी 1 मिनिट. 1 minute. This is 1 C1. 1 plus C1 is equals to lambda by 2. So we can write this as, from equation 7 and 8 we can write the value here. इथं पहा लॅम्बडा y of pi is equals to 1 आहे, इथं minus C1 आहे, minus C1 इथं लेफ्टला जाऊन plus C1, that will be 1 plus C1. Now from 7 and 8, that means put the value of C1. So 1 minus C1 means lambda by 2 which is equals to lambda by 2. So 1 is equals to lambda by 2 plus lambda by 2, that is lambda is equals to 1. Therefore we can write C1 is equals to, now if we will get the value of lambda, then we can find the value of C1. So C1 is equals to minus lambda by 2, that is equals to minus 1 by 2. In this way we can find the values of lambda and C1. We can find the values of lambda and C1. Now dear student, अभी देखो हमें दो values we have discussed, C1 and lambda, but there is also in the general solution there is also third arbitrary constant, that is C2. Now C1 and lambda we will get by using the boundary condition. We have calculated here by using the boundary condition, but now we have to calculate C2. Now we can find the value of C2 by using the constraints, given constant, condition of the constants. Also by the given constant condition, integral from 0 to pi y dx is equals to 1. Put the value of y, integral from 0 to pi. We have calculated the value of y. What is that value of y? Y means C1 cos x plus C2 sin x plus lambda by 2. C1 cos x plus C2 sin x plus lambda by 2, bracket close dx, which is equals to 1. Now we know that the value of C1 and C2, C1 means minus 1 by 2, C2 is unknown and lambda is 1. So put these values. So integral from 0 to pi minus 1 by 2 cos x, C2 is unknown as it is sin x, again lambda by 2, lambda is 1, so we can write 1 by 2 dx is equals to, okay, so it will be right side काय दिले right side पहा, right side is given 1. okay, आता याचं इंटिग्रेशन कॅल्क्युलेट करू आपण. इंटिग्रेशन कॅल्क्युलेट करत असताना हे इंटिग्रेशन सोल्यूशन करत असताना सिंपल इंटिग्रेशनच्या प्रॉपर्टीज वापरा. सिंपल इंटिग्रेशनच्या प्रॉपर्टीज वापरा. पुट द इंटिग्रेशन. सो we can calculate directly integration. Minus 1 by 2 as it is. What is the integration of cos x, students? That is a sin x. Plus C2 as it is. Integration of sin x is again cos x minus cos x, so we can write this minus here, plus integration of 1 by 2, which is a constant with respect to x, it will be 1 by 2x over the limit 0 to pi, which is given by 1. Is it okay? Now put the upper limit and lower limit, so we can put the upper limit minus 1 by 2 sin pi minus C2 cos pi plus pi by 2, this is the upper limit, minus lower limit, minus 1 by 2 sine 0 minus C2 cos 0 plus 1 by 2 0 which is equals to 1. Is it okay? हाँ ठीक आहे. आता now you tell me the values. आता याला particular value काढा. sin pi 0, cos pi minus 1 plus pi by 2 minus 0 minus C2 cos 0 means 1 plus 0 which is equals to 1. So C2 plus pi by 2 plus C2 which is equals to 1. बरोबर आहे का? चेक करा. नाही आलं तर विचारा. So C2 2 times of C2 which is equals to 1 minus pi by 2. Is it okay? Now C2 is equals to 1 by 2 in a bracket 1 minus pi by 2. That means 1 by 2 minus pi by 4. This is the value of C2. Okay. In this way, we can obtain the arbitrary constants. In this, hence the particular solution is y is equals to C1 cos x plus C2 sin x plus lambda by 2. That is y is equals to C1 ची value किती आली रे student? C1 means minus 1 by 2 minus 1 by 2 cos x. C2 means 1 by 2 minus pi by 4 into sin x, and lambda means 1 by 2. So this is the required extremal of the given functional h. So this is the required extremal of the functional h, extremal of the functional h, and which has the particular solution, and which has particular solution of isoperimetric problem. Isoperimetric problem. Do you understand this? अशा पद्धतीने हे कंप्लीट सोल्यूशन होतं. समजलं का रे तुम्हाला? हा प्रॉब्लेम टोटल समजला का स्टुडंट्स? हे समजलं ना सर्वांना? If you have any doubt, then you can ask. Okay? If you have any doubt, then you can ask. I shall solve such problems. Okay? तर होमवर्क साठी मी प्रॉब्लेम देतो. Okay, I shall solve this. Find the functional. होमवर्क साठी देऊ का उद्या घेऊ रे हे प्रॉब्लेम? आणखी सॉल्व करताय ना? हे सॉल्व कराल का? का होमवर्क देऊ? ठीक आहे, होमवर्क देतो तुम्हाला, सोल्यूशन पाठवून देतो. ओके, होमवर्क. फाइंड द फंक्शन y of x for which integral from 0 to 1 x square minus y dash square dx is a stationary and given that y of 1, y of given that integral from 0 to 1 y dx which is equals to 2. The boundary condition are y of 0 is equals to 0, y of 1 is equals to y of 0 is equals to 0, y of 1 is equals to 0. This is the first problem. Second, find the extremal of I is equals to y of x which is equals to integral from x0 to x x1 y dash dx, given that integral from x1 to x2 y dx is equals to c. Okay, now find out, now you have to find out the general solution of second problem. We have to find out the particular solution of first problem. इथं बाउंड्री कंडिशन दिलेत y of 0 is equals to 0, y of 1 is equals to 0. सोडवता का रे? ओके, तर हे प्रॉब्लेम सॉल्व करा. काही अडचण आली तर विचारा. Now we shall provide the answer of these problems. Okay, सोडवाल ना? If you have any doubt regarding these problems, then you can ask me. Okay.